Hello everyone. In this lecture, we are going to solve the problems on Z transform using properties of Z transform. In this lecture, we are going to consider the two properties which are first one is the linearity property and the second one is change of scale property. So let us go to solve the examples. In the examples, we are going to find Z transform and a region of convergence for the given sequences. Consider the first sequence whose general term is f of n is equal to 2 raised to n plus 3 raised to n for n greater equal 0. So let us see the solution. Z transform of f of n is equal to Z transform of, this is the given f of n, which is 2 raised to n plus 3 raised to n. And now you here use the linearity property that will give us Z transform of 2 raised to n plus Z transform of 3 raised to n. So this is by linearity property. Now use definition of Z transform that will give us for first sequence, that is 2 raised to n, the Z transform will be summation n from 0 to infinity 2 raised to n Z raised to minus n. How we have taken here n from 0 to infinity? Because in the example itself we have been given n is greater equal 0. Plus similarly for the second sequence in this summation, its Z transform will be given by summation n from 0 to infinity 3 raised to n Z raised to minus n. Now put values of n one by one starting with 0. That will give us the expression 1 plus 2 into Z raised to minus 1 plus 2 square into Z raised to minus 2 plus so on for the first summation, and 1 plus 3 into Z inverse plus 3 square into Z raised to minus 2 plus so on for the second summation. Rewriting the terms in both the summations, we will be getting further expression as 1 plus 2 upon Z plus 2 square upon Z square plus 2 cube upon Z cube plus so on, plus for the second summation it will be 1 plus 3 upon Z plus 3 square upon Z square plus so on. We can clearly observing this thing here that both the summations, they are in geometric progression with first term as 1. First GP has common ratio 2 upon Z and second GP has common ratio 3 upon Z. Hence, infinite sum will be given by first term divided by, so 1 divided by 1 minus common ratio which is 2 upon Z plus for the second GP it is first term again 1 divided by 1 minus common ratio for the second GP common ratio is 3 upon Z. First one is true for modulus of common ratio, that is 2 upon Z strictly less than 1, and second one is true for modulus of common ratio, that is 3 upon Z strictly less than 1. Simplify this expression, we will be getting it as Z divided by Z minus 2 plus Z divided by Z minus 3. And if we simplify expression for region of convergence, that will give us mod Z is greater than 2 and mod Z is greater than 3. And hence Z transform for the given sequence is f of Z is equal to Z upon Z minus 2 plus Z upon Z minus 3. And combinedly this is true for or in the region of convergence mod Z greater than 3. So this is the required Z transform of the given sequence with the region of convergence. Now consider the second example in which general term of the sequence is f of n is equal to 3 raised to n into cos of 2n plus 1 for n greater equal 0. Let us see the solution. Now, first of all, we will consider g of n as cos of 2n plus 1 because here we are going to use the change of scale property. Already we have discussed its formula, isn't it? That's why here we have called this second term in f of n, which is cos of 2n plus 1, as g of n. Now, we will simplify this cos of 2n plus 1, which is cos 2n into cos 1 minus sin 2n into sin 1, using the formula cos of a plus b, which is cos a into cos b minus sin a into sin b. Now further, obtain the Z transform for this sequence g of n. So it will be Z transform of g of n is equal to Z transform of this term cos 2n into cos 1 minus sin 2n into sin 1. Wherein this cos 1 and sin 1, they are constant terms. Therefore, using linearity property, we can rewrite this term as cos 1 into z transform of cos of 2n minus sin 1 into z transform of sin of 2n. Using standard formulae for z transform of the functions cos of alpha n and sin of alpha n, where alpha is 2, we will be getting z transform of g of n as cos 1 into z minus cos 2 divided by z square minus 2z cos 2 plus 1 minus sin 1 as it is, and z transform of sin 2n is z into sin 2 divided by z square minus 2z cos 2 plus 1, and both are true for mod z strictly greater than 1. So this we have written using z transform of the standard functions. Now we will simplify this term further, for which first of all we will recall change of scale property, which is given by z transform of a raised to n into g of n is equal to g of z upon a. How to get this term? Whatever the z transform of g of n which we have obtained, in that replace z by z upon a. Therefore, Z transform of f of n, that is f of z, is given by cos 1 into, so wherever z was there in the in the last expression, replace it by z upon 3, because our a is 3 here. So z upon 3 into z upon 3 minus cos 2 divided by z by 3 bracket square minus 2 into z by 3 cos 2 plus 1 minus sin 1 into z by 3 into sin 2 divided by z by 3 square minus 2 into z by 3 cos 2 plus 1. Simplified further, uh, the region of convergence will be now mod of z upon 3 strictly greater than 1. Simplifying it further, we will be getting it as f of z equal to cos 1 into, now we have multiplied numerator and denominator by 9. Therefore, we got our expression as cos 1 into z minus 3 cos z divided by z square minus 6z into cos 2 plus 9 minus sin 1 into 3z sin 2 divided by z square minus 6z cos 2 plus 9. Further simplification will give us f of z is equal to z square into cos 1 minus 3z into cos 1 into cos 2 divided by z square minus 6z cos 2 plus 9 minus 3z into sin 1 into sin 2 divided by z square minus 6z into cos 2 plus 9. It will give Further, and here region of convergence is mod z greater than 3, simplifying this expression. Further, it will give us f of z is equal to, now as denominator was same, we have added numerator, and that gave us f of z is equal to z square into cos 1 minus 3z cos 1 cos 2 plus 3z sin 1 sin 2 divided by z square minus 6z cos 2 plus 9 for mod z greater than 3. Now here we will take 3z common and we will use the formula for cos 1 cos 2 plus sin 1 sin 2. That is cos A cos B plus sin A sin B, which is cos of A minus B. So that will give us z square into cos 1 minus 3z cos of 1 minus 2 divided by z square minus 6z into cos 2 plus 9 for mod z greater than 3. Cos of 1 minus 2 is cos minus 1 and cos minus 1 is cos 1. So simplification will give us f of z is equal to z square into cos 1 minus 3z into cos 1 divided by z square minus 6z into cos 2 plus 9 for mod z strictly greater than 3, and hence final z transform for the given sequence is f of z is equal to z into z minus 3 into cos 1 divided by z square minus 6z into cos 2 plus 9 for mod z greater than 3. So always we will try to get z transform into the most simplified form. So I hope you understood this, how we have used the linearity property and change of scale property to obtain Z transform of the given sequence. In the next lecture, we are going to use the next two properties. Thanks for watching this video.